So that will be 2 comma negative 7. And then here, 2 times 3 squared minus 8 times 3 plus 1 is negative 5. And then when I plug in the 4, I get 1. Four comma 1. Okay. Do you guys notice a pattern? Huh? What's happening to the y values? It starts with an S. No. What is it? What do you see?
Symmetry.
There is some symmetry, right? Look at the y value here. It's negative 7, right? And then the one before and after is negative 5. And then the one before and after that is 1, right? Remember, that's what happens with the parabola. So let's go ahead and graph these. 0 comma 1. 1 comma negative 5. 2 comma negative 7. All right. So let's graph this. Okay. So you notice how this is the point, right? And then after that, like before and after, it's the same value, negative 5. And then before and after that, it's the same value, positive 1, right? So that point right here, that's the vertex, right? And then from there, as you go out, the y values are symmetric, just like we did in chapter 2, right? Okay, so that's how we can identify that this is the vertex, and so on. Okay. A parabola, right, is like any math teachers, like it's one of our favorite shapes, right? And the reason is because there is so much symmetry and harmony happening in a parabola. You already saw the symmetry, right? And if you take your parabola, divide it down the middle vertically and fold over the two ends, they will match perfectly, right? So that line that we can fold over, this one here, there is an imaginary line. We call that the axis of symmetry. Okay, so to graph a parabola, once you figure out what the axis of symmetry is, you can then, right, if the axis of symmetry we know is at x equals 2, we can then pick points immediately around 2, so 1 and 3, and then 0 and 4, and that's how we can get our good points to graph a nice parabola, okay? So it all centers around the vertex and the axis of symmetry. So let's figure out how we can find the vertex and the axis of symmetry. So here are some things about parabolas that you just have to memorize, okay? First of all, to get the equation for the axis of symmetry, the formula is x equals negative b over 2a. Okay, so where does the b and the a come from? Look here, these coefficients are a, b, c. So in this problem here, what's a? 2. What's b? Negative 8. You got to take the sign with it. And c? 1. Okay, so here this axis of symmetry was at x equals 2, right? X equals 2. The way to find that is negative b over 2a. Okay. Now, once you find the axis of symmetry, that number, x, right, whatever you get for x, that becomes the x coordinate of the vertex, right? So that's the same number from here. So then how would we find the y coordinate of the vertex? Not flip it. Okay, so if I do this for that problem, right? For this problem, x equals negative b over 2a. X equals negative b, that's negative 8, over 2 times 2, 4. Okay, now I know, 2. Now I know x is 2. At x equals 2, there is a vertex. How would I find the y value? What do? Take x, plug it back into the function. Okay? So to find the y value, okay, plug x back into the function. Okay. Now, let's talk about y-intercept. Y-intercept is when the graph intercepts the y-axis. So right here, y-intercept. At that point, what's the x value here? 0. So the y-intercept is a point where it intercepts the y-axis, and the way you give it is 0, comma, c. Okay? We've done x-intercept and y-intercept before. You have to put it in coordinate form. All right, let's move on. Yep. The function. Okay, let's move on to the next one. Yep. Okay, yes, but okay. Y-intercept is when x is what? 0. You shouldn't have to write anything down for y-intercept. When x is 0, how much is this function going to equal? 5. That's it. But the way you write it is 0, comma 5. Okay. Axis of symmetry. It's going to be x equals negative b over 2a. So 10 over 2 times negative 5. How much is that? Negative 1. So for axis of symmetry, you have to write x equals negative 1. X equals not just negative 1, please. And then what's the x coordinate of the vertex? The x coordinate is just negative 1. And then we have to find the y coordinate later. So whatever this is, that's the same. Okay, let's make a table of values. So here's what you do. The negative 1 here goes in the middle of your table. Okay, then from that, so negative 1 is here. Then from that, you go out, right? So for example, we're going to go to negative 2 and 0, right? 1 out, 1 out, 1 to the left, 1 to the right. And then 2 to the left, negative 3 and 1. Okay, and we're going to plug them in very quickly, right? I'm just going to give you guys the answers for these. Here we get negative 3, comma, negative 10. Negative 2, comma 5, negative 1, comma 10, and then these are going to be the same, right? Okay? All right. So, vertex, I always graph the vertex first. Negative 1, comma 10. Then it's negative 2, comma 5, and then mirror it on the other side. And then negative 3, negative 10. And mirror it on the other side. Okay? All right. Look at how narrow this is. So there will be a tendency to make this like an upside down V, but please don't do that. Take a look at what I do. At the very top, I kind of make the arc of the parabola like this at the vertex, right? And then I extend those points down. Okay? Let me make that nicer. All right? You can put arrows or you don't have to put arrows. I don't mind. All right. So do you see where the axis of symmetry is? Is that x equals negative 1? Okay. Now, before I take your question, take a look. This parabola is facing down, whereas the one before was facing up. The reason why it's facing down is because the a value here is negative. Okay? Because a is negative, it faces down, right? So a is less than 0, right? A is negative 5. Therefore, the parabola will face down. Okay, Todd, very quickly. Did you have a question? A was negative. Parabola faces down. That means this point here is the highest point in the parabola. We call that a maximum. Here, A was positive. Parabola faces up. This point here is the lowest part in the parabola. We call that a minimum. All right? So these are important terms. It's like a peak and a valley, but mathematically, elegant, sophisticated math students, we talk about a maximum or a minimum value. So again, A is positive, it's got a minimum. It's counterintuitive because a lot of students are like, oh, positive means maximum. No, visualize it in your head. Positive A faces up, it's got a minimum. Negative A faces down, it's got a maximum. Okay? Okay, now, here is what's important. When I ask you, where is the minimum or the maximum, that's the x coordinate. Okay? So, correct. The vertices will either be a maximum or a minimum. Okay? So, a maximum is the highest point or the minimum is the lowest point. And of course, it's also the vertex, right? Now, let's talk about this. So when I ask you, where is the minimum or the maximum, right? That would be the x value. Okay? Now, I don't want to use the word, that would be the x coordinate. Okay? The y coordinate is the minimum value or the maximum value. All right? It's also here. So when I say, what's the minimum value? That's the y coordinate. Okay, what's the maximum value? That's the y coordinate. So here, where is the maximum at x equals -1? What's the maximum value? 10. Yeah? It sounds like, potato to you, but man, does it make a difference. Okay. Let's talk about domain and range. Domain for all quadratic functions is all real numbers. So from this point on, I don't want any single one of you to think, even for a second, oh wait, what was domain again? No, quadratic function, all real numbers. Range is connected to the vertex, the y value of the vertex, because the range is either starting at the vertex going up or starting at the vertex going down. So it's either y is greater than the minimum value, y is less than the maximum value.
Oh, here it says minimum 5.
Okay, go ahead and fix it.
So
One of them is a maximum. Which one should be a maximum? Top or bottom? Bottom. Okay. So determine whether each function has a minimum or maximum value and find that value, then state the domain. Okay, so write off the first one, minimum or maximum.
Maximum, but I had a
Oh yeah.
question. When you're doing the range,
Uh-huh.
would you do less than or equal to? Or
Yeah. Because it hits that point. Okay, so this one does have a maximum. Okay, so now let's figure out where the maximum is. Okay, so let me do this first. So we're going to do x equals -b over 2a. So x equals, what's b? Right, -8 over 2 times -4, 1. Okay? All right. That's where the minimum or maximum is. So what's the value? You have to now plug it in. F of 1 is equal to -4 plus 8, 4. So to answer these questions, we did the preliminary work. This has a maximum. Okay. You can do two things. You can either say the maximum is at 1, 4, or you can say f of 1 is equal to 4. Okay? F of 1 is equal to 4 means y is 4 when x is 1. I want you guys to get used to this notation before you get to pre-calc or calc. Okay? All right. What else do we need to find here? Find the value. We found it. Domain is all real numbers. Okay, range. Since it has a maximum, everything is below it. So y is less than or equal to 4. Okay? Go ahead and do the next one, please, while I answer this question. Yeah.
Where did the 4 come from?
we plugged 1 into here. Negative 4 times 1 plus 8 times 1. Okay? All right. So here, x is negative b over 2a, negative 3. Right? So f of negative 3 is what? 9 over 2 minus 9 plus 1. No, because you square it. Yep. Okay. So that would be. So that's negative 7 over 2. Okay. All right. Does this have a minimum or maximum? Go ahead and yell it out. Minimum or max? Minimum. So we say f of negative 3 is negative 7 over 2. No. If it's minimum, it's not negative. If it's negative, it's not minimum. A is positive, right here.
Oh, it's in the original.
A is positive, so it faces up, it's got a minimum. Okay, what's the domain? All real numbers. And the range this time? Greater than or equal to 7 over 2, negative 7 over 2. Okay. Now, okay. Let's go ahead and take out your calculators, please. Right, so 9.7 x squared. Okay, right. We have to find minimum and maximum. So once you graph it, it's going to look like this. You can't even see the minimum or maximum. This is not a good graphing window. One thing you can do is you can do two things. You can manually adjust the windows, or I always like to move these out, or you can go to menu, window zoom, and let's just zoom out. It says, where's the new center? I just click like in the somewhere in the center, okay? And if you keep clicking, it'll zoom out for you. Okay, now you can see it. Okay? Now, we're gonna find, so we can escape from here. Escape before you do anything else. Now we're gonna find the minimum and the maximum. So go to menu, analyze graph. Is this a minimum or a maximum? Minimum. And then again, it's lower bound and upper bound. So this, right, same thing. So there it is. Okay? Okay. So I'll answer questions in a sec, but let me show you how to write down the answers. So it's going to be, there are two ways of writing this, okay? In coordinate form, it'll be 0.67, negative 13.36. And then in function notation, it'll be f of 0.67 equal to negative 13.36. Okay? All right, if you got those two answers, if you got those two values, then go ahead and plug in the other one. For the other one, you might have to do 3 over 5 in parentheses. Yeah, just do Control Delete and then in its place put this one in. Yep. Okay. So f of 3.33 is equal to negative 1.33. Okay. Now for this one, was this a minimum or a maximum? This is a maximum. So you can say maximum is blah, blah, blah. And then these were minima, right? Okay. All right. Let's move along. If you still have calculator questions, let's address them after this. Right now, put the calculators away. Let's do this next problem. This A and B, yeah, but not necessarily. Not.
If it's like this, if it's like hard.
Okay. From this section, everything other than this can be no calculator. The only thing that would be calculator only is this one. Okay, let's do this one. determine the function represented by the graph. For any one of these, this is exactly like what we did in section 2, or I'm sorry, in chapter 2. You're given your vertex and what else are you given? A point, right? You have a vertex and a point, yeah. So here this becomes x comma y, and we're going to plug it into our equation in standard form, which is ax squared plus bx plus c. Okay, so what's y here? Negative 7 is equal to a times x, negative 1 squared, plus b times negative 1 plus c. Okay, if I was up to, okay, if I were you, okay, I would, when I'm plugging these in, just take a minute and just put them in the parentheses, because sometimes when people are squaring in their head, it's just like the negatives are getting lost. Okay, so this is going to be, whoops, negative 7 is equal to a minus b plus c, right? But what is c? Here, this is the y-intercept, right? So this is 0 comma c. So I can put that over here and make that minus 6. Okay? So little by little, we got to put together the pieces of the puzzle. Huh?
Oh, sorry,
Okay. What we also know from here, since this is the vertex, right? We know that the x-coordinate of the vertex is negative b over 2a, right? In this case, what's the x-coordinate of the vertex?
0.
Negative 1, right here. This is the vertex here. Okay? So negative 1 is equal to negative b over 2a, right? So when these go away, 2a is equal to b. Okay, so, huh? I multiply, so 1 is equal to b over 2a, multiply by 2a, multiply by 2a. Okay, so let's come back to our...
So wouldn't that be minus, oh, no.
Okay, so here, when I add 6 to both sides, what do I have? Negative 1 is equal to a minus b. But this means negative 1 is equal to a minus, what's b? 2a. I know. It's like pieces of a puzzle. Huh? I add 6 and I add 6.
Oh, it's a negative.
Negative 7, yeah. Okay, so negative 1 is equal to how much? Negative a, so what's a equal to? 1. I know. So I got a, I know c, now I need b, but what's b? B is equal to 2a, so b is equal to 2 times 1 is 2, so now I got a, I got b, I got c, I got all the pieces of my puzzle, so I can say y is equal to, a is 1, x squared, plus 2x minus 6, but of course we don't write 1x squared, so it'll just be x squared.
If you're on 1x,
Okay, so